Hello, good afternoon everyone. My name is Nicole Castillo, I'm from Mexico and currently I'm studying computer science at Universidad de Sonora. Today I'll describe one of the projects I work on as part of my internship in the 2020 Cross-Undergraduate Summer Research Experience program, which is a reproducible performance comparison of machine learning libraries using Popper. First of all, let me get started by explaining what Popper is for those of you who don't know. Popper is a tool for defining and executing container-native workflows in Docker, as well as other container engines, as we'll see in further talks. So basically, you're able to define a workflow in a YAML file and then execute it with just a single command. This is how a Popper workflow file looks like. So there are steps, uses, arcs, and what is happening here? Popper takes each step, initializes a container for it, and then runs the given command, passing it the given arguments. It essentially automates container-related tasks so that others don't have to guess what was done and instead can see and rerun them easily. If you would like to know more about the workflow syntax or their functionality, please feel free to visit the documentation page. It is very well explained. For this project, I chose a library called Xlearn. What is Xlearn exactly? According to the repository, this is a high-performance, easy-to-use, and scalable machine learning package that provides a linear model, factorization machines, among other tools, in order to solve large-scale machine learning problems. Also, they included some performance comparison charts, which are these ones right here. The one I reproduced was the one that compares their linear model in opposition to live-linear, so that is the other library I used. To accomplish this, I focused on one of their demo examples that uses this model, Hex Classification. But according to the UCI website from where this data was obtained, this is a classification problem to distinguish between a signal process that produces Higgs bosons and a background process which does not. Due to size issues, they were only able to use a subset of the dataset in the demo, but with a Popper workflow, I was able to use all of it by extracting it directly from the website. Now, I'll describe each of the steps that the workflow performs. The workflow first builds the image that is in charge of installing the libraries and dependencies necessary for this to work smoothly. Then it downloads and verifies the complete Higgs dataset from the UCI website, which has 11 million entries. Then the workflow proceeds to prepare the data by converting it in the needed format. The next step is to run the benchmark that compares both libraries, and the final step consists of creating the chart that shows the results including error bars. So, as we can see, the reproduced chart is very similar to the one Xlearn has in their repository, showing that Xlearn is way below than live-linear as expected. To reproduce this chart, these are the only steps that are needed. First, you have to clone the repository, then you need to install Popper just with this simple command, and finally, just run the workflow. So what were the project's objectives? First, to serve as an illustration of how workflows can be useful in the area of machine learning to reproduce things, to encourage different projects such as Xlearn into using Popper, to be able to participate and contribute to open source projects, and also personal growth, not only in the technical field like making my first pull request and getting to know more tools, but also developing my soft skills such as communicating my doubts and ideas. I'm very grateful to my mentor in this project, Ivo Jimenez, to Cross, and also to the others in the crew. They were really helpful. Thank you all for attending, and please feel free to ask me anything or add any comments.